Good morning, my name is Luigi Agostini and today I'm going to give you a short introduction about alkanes. What I would like to remember by the end of the lesson is the following. First of all, you should be able to define what an alkane is. Second, you will know what's the main natural source of alkane. And finally, we will outline some of the chemical reactivity of the alkanes. So, alkane is a specific class of hydrocarbons. It's composed only by carbon and hydrogen atoms. It can be described by the general formula CnH2n plus 2, where n is whatever integer number we want to use. So, for example, if we use n equal 2, we will gain C2H6, which is ethane. If we put in n equal 3, we will get C3H8, which is propane, and so on. The structural representation of the ethane, for example, is this one, where we can see that the only kind of bond present in this molecule is a single covalent bond between carbon-carbon atoms and carbon-hydrogen atoms. Therefore, in the alkanes, we will have the highest possible number of hydrogen atoms, and this is why they are also called saturated hydrocarbons. Now, what I would like you to remember already is that going up with the chain length, passing from C2, C3, C4, C5, the chemical and physical properties of the alkanes change. Specifically, one chemical property that we are going to use later on to separate them from the raw mixtures is the boiling points. So, increasing the carbon-carbon chain of an alkane will automatically increase its boiling point. Shorter chain alkanes will have a lower boiling points than long chain alkanes. This is the specific property that we will be used to separate them according to their different boiling points. Now, let's see if you understood exactly what it is an alkane. If, for example, I gave you these three compounds, by now you should be able to tell me which one is an alkane. Let's see, for example, compound number 8, it's got only hydrogen and carbon atoms, but there is a double bond between the first and the second carbon atom present on the molecule. Therefore, this is not an alkane. As we shall see in the next lesson, this is an alkane. If we move on compound number B, we see that there are carbon-hydrogen bonds, all single bonds. However, there is a carbon bonded to an hydroxy group. Again, this is not an alkane compound. Compound number 3, we have carbon-carbon single bonds, carbon-hydrogen single bonds. There is no other kind of compound in the molecule, therefore this is an alkane, and this is the only alkane between the three of them. Now that we have seen what an alkane is, we need to understand where do we get them from, how can we separate them according to the different chemical properties, specifically the boiling points. So alkane are extracted from crude oil, which is brought to surface from oil wells all around the world. Once we take it to the surface, we carry it in a refinery, in a chemical processing farm, where it will undergo a process called fractional distillation. In order to carry out this process, we will need a fractionating column. A schematic representation of the fractionating column is the following. I hope you can see it well, but it's reported also on your book. In a fractionating column, we will have the bottom of the column which will have the highest temperature. In this example is around 350 degrees. And the top of the fractionating column which will have the lower temperature, which is in this example around 25 degrees Celsius. The crude oil will enter the fractionating column at this stage, essentially as vapor and liquids. The non-volatile liquids will leave the column at the very bottom, as bitumen mainly, while the increasing volatiles components will start to rise up the column, and they will start condense gradually according to their different boiling points. Therefore we are going to collect the liquid fraction of different alkanes at different height of the fractionating column. Of course, we won't get a single molecular weight fraction at each stage, but we will get a very narrow distribution of molecular weight for each fraction. It's worth noticing, though, that there are alkanes so volatiles, like butane, ethane, propane, which we won't be able to condense in any of the step we meet in the fractionating column, and we will be only able to collect them at the very top of the column as gases. Why it's important to separate them? Well, it's important because different fractions of alkane can be used for different commercial purposes. Especially the low molecular weight alkanes can be used as fuels, can be used as are used to warm up our apartments. They are actually our main font of energy, our main source of energy. However, all the alkane fractions are important because with other longer chain fraction we can get the starting material for to build polymers, for example, and for plastics or any starting material, most of the starting material which is used in the chemical industry. Now let's talk a little bit about the reactivity of the alkanes compound. As we have seen, the alkane compounds are composed of single covalent bond between carbon-carbon, carbon-hydrogen atoms. There is no big electronegativity difference between the carbon and the hydrogen atoms. Therefore, there is no polarity in an alkane. There is no difference of charge between the carbon and the hydrogen, which means that the alkanes are not really chemical reactive towards electrophilic or nucleophilic reactions. Which is not the case, for example, if we substitute one of the hydrogen atom with an halogen, X in the example. In this case, we will have a partial negative charge on the halogen and a partial positive charge on the carbon, which could undergo a nucleophile attack, and the negative charge on the halogen atom could potentially undergo an electrophilic attack. However, alkanes do have some kind of chemical reactivity. In particular, they can undergo combustion to give carbon dioxide and water, and they also undergo radical reaction under the influence of UV light, and therefore we can substitute the hydrogen atoms with more reactive compounds like halogens or radical groups or radical groups. So for today the lesson is over. Tomorrow we're gonna go a little bit more in detail on the chemical reactions of the alkanes. Thank you very much. Goodbye.